In this question, we're going to be using the binomial formula actually in Excel to answer these questions here. Here we have a probability P of 39% and we have a sample size of 27. So we have P equals 0.39 and N equals 27. So I'm going to set that up in Excel here. So we're going to need X, then we're going to need N, we're going to need P. N is going to be 27 and P is 0.39. And we are going to be calculating probability. Let me just call that prob here. We're going to need the probability that X is equal to, and then we're going to need the probability that X is less than or equal to. Now in Excel, the formula is binom.dist, binomial distribution. So we're going to need the X value, that's the number of successes, comma, we're going to need the number of trials, N, comma, we're going to need the probability, comma, and because it is not cumulative, for the equal one, we're going to put false or 0 here. Now the answer shown here is because it's assuming we have a 0 for X here. So I'm just going to put a value like 5 for X for now. And let me just highlight that yellow. And for this one here, we're going to make it cumulative true. So binom dist, again, number of successes, comma, number of trials, comma, probability. And this time we'll type true or 1. Okay, and that will give us the cumulative probabilities. That is the probability from 0 added up to the value of X here. So for the first question, we want the probability that X equals 10 exactly. So all we just need to do is put in 10 here, and that will give us the required probability over here. For the second one, exactly 18 do not quit. So there are two ways to look at this. We can say exactly 18 do not quit. That means the remainder, 27 minus 18, that will be 9 quit. So we can say X equals 9 will quit. Another way to do that is to still use X equals 18, but then P will now be 1 minus 0.39, and that will give us the same results. So none of them quit after first rejection. It just means X equals 0. So we're going to put X equals 0 there. Now at most 9 means maximum 9. So we're looking for the probability that X is less than or equal to 9. So we already have that here. Just that we're going to be using the cumulative value here. Now part E, at least 8 quit. So at least means X is greater or equal to 8. We want everything from 8 on, 10, 11, all the way on. That means if we subtract everything up to 7 from 1, we can get everything 8 and above. So this will be 1 minus probability that X is less than or equal to 7. So if we put 7 here, we get this probability, and then we subtract that from 1. 1 minus that will give us the required answer there. Part F, more than half quit. So if N is 27, half of 27, so X is greater than 27 over 2. 27 over 2 is 13.5. Basically saying we're starting at 14. So and if we're starting at 14, we want 14 and up. So to get that result, we'll have to subtract everything up to 13. So this will be 1 minus probability of X less than or equal to 13. In part G, at least 8, but no more than 16. So at least 8 will look like this. No more than 16 will be that. Essentially, we're looking for X between 8 and 16 inclusive. So in that case, we'll have to take everything up to 16 and remove everything below 8 from it, because we have 8, 9, all the way to 16. That's what we want. We have values below 8 here. We have to take them out. So we take everything up to 16 and subtract everything less than 8 from it. So So it's going to be probability that x is less than or equal to 16 minus probability that x is less or equal to 7. That will give us the result there. Now for this next one, less than 5, greater than 10. So in this case, less than 5 will be x less than or equal to 4. Greater than 10 starts at 11. So that is plus x greater or equal to 11. Or we can say 1 minus everything all the way to 10. Okay, so we add these two and that will give us the answer there. Now we need the mean and standard deviation. So we know the mean, mu, is just n times p, and the standard deviation is the square root of npq, which we need accurate to 2 decimal places. And then finally here, if we expect to find 54 that quit, so in this case, that is the number of successes. So if we expect to find 54 successes, how large a sample should we select? So we know the mean is the expected value, which is n times p. So if we expect on average to find 54, what should n be if our p is 0.39? So n is going to be 54 over 0.39. So if we do that here, equals 54 over 0.39, that will give us 138.4. Now, if you round that, it will be 138. But if you do 138 times 0.39, you will get less than 54. So you won't be able to get 54 salesperson. So you have to round it up to the next integer. So you have to round it up to the next integer 139 in order to get the sample size required. And that's it.